Section 1.4 is on transformations of graphs. This is an important section. We're going to use this quite a bit through this course, so watch it twice or something, I don't know. Okay, here we go. You'll see on your worksheet here, I really had to cram. My goal is to always get everything on one piece of paper, two sides, right? I had to really cram here, so I'm sorry it's a bit squished. The first thing we need to do is we need to get familiar with 5 mother functions. Remember we talked about the mother function last year with y equals x squared, so this should actually, this should actually be a review. Y equals x squared, and we've actually done y equals 1 over x before. We have done y equals the absolute value of x before. It's the other two we haven't done. But let's pretend we hadn't even done them before, and we're going to graph these. Now you want to get to the stage where you know these graphs, and you can graph them within 20 seconds. Okay, you don't really want to have to make a table of values for every single time you have to graph these. But for today, let's imagine we've never graphed them and we do have to do a table of values. So we're going to make a table of values to figure out the graph, and let's use the values -3, -2, -1, 0, 1, 2, 3. It's good to have some negative values and positive values. So if we're graphing y equals x squared, we're plugging all these numbers into the x. -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, sorry, and 3 squared is 9. We're going to graph those points. -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. Hey, it looks like a parabola. And that's what we expected. And last year the way we did this is we talked about the vertex being at 0, 0, and yes indeed it is. You could do your over 1 up 1, over 1 up 3. But as I said, if you didn't know how to graph parabolas, if you'd never taken my course last year, or if you slept through the whole course, which some of you did, then you could always use your table of values and you could figure it out. Now the tricky thing about it is sometimes it's not so obvious which x values to use. But for these mother functions here, -3 till 3 are good values, except for the one exception for that is this one down here, the square root of x. We'll talk about that in a second. Now, why are these called the mother functions? Because they give birth, if you like, to a whole bunch of different other functions. Like this one parabola is the basis for every other parabola that we create. And we talked about this last year. We do transformations to this parabola to get different parabolas. Okay, we'll come back to that in a second. Let's move on. Let's do y equals x cubed. Hey, we've never done this one before. This is going to be exciting. It's a new graph for us. So since we've never done it before, we kind of have to do a table of values. Let's go from -3 up to 3 again. -3 cubed, that means -3 times -3 times -3, you get -27. -2 cubed is -8, -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, and 3 cubed is 27. Okay, we can't graph the first point, it's way off the graph, so we can graph -2, 8, we can graph -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. And so the way a cubic function, that's what this is, a cubic function, the way it looks is kind of like this. It goes down very fast, and it goes up very fast. Ah, darn it. As I've said many times, it's very difficult to do these precise graphs on my... I got rid of the what was it, 2, 8 right there. It's difficult to do these graphs on my bamboo, as this thing's called I'm writing on. Okay, there you go. That is the y equals x cubed graph. Okay, let's do y equals absolute value of x. We did this one last year, so you might recall already what it looks like. If you don't, you could always do a table of values. The absolute value of -3 is 3, the absolute value of -2 is 2, absolute value of 1 is 1, 0, absolute value of 1 is 1, 2, 3. Remember this? You just get the V shape. Goes something like this. Yeah? Okay, and it goes on forever, so put our lines, arrows I mean at the end. Sorry, I'm kind of going fast here. Y equals 1 over x. Believe it or not, we did this one too. Don't know if you recall, but we did this. So let's use the values -3, -2, -1, 0, 1, 2, 3. 1 over -3 is -1/3. and then 1 over negative 2 is negative a half. 1 over negative 1 is negative 1. 1 over 0 you can't do. 1 over 1 is 1. 1 over 2 is 1 half, and 1 over 3 is a third. So let's graph some of those points. Negative 3 and negative 1/3. So it's negative 3 and just down a tiny bit. Negative 2 and negative a half. Right there. Negative 1 and 1. 0 you can't do. 1, 1. 2 and a half. 3 and a third. Now, when you look at that, you might be like, what? I don't remember doing this kind of graph. But do you remember, this is the ones where if it's a reciprocal function, that's what this is called, a reciprocal function, you have your asymptotes. There's an asymptote at the x-axis. In this case, there won't always be, but in this case, there's an asymptote at the y-axis. And basically, remember that the curve is going to get closer and closer and closer to this asymptote, but never reach it. It's actually going to go closer and closer and closer to this asymptote and never reach it. It's going to go closer and closer to this asymptote, whoops, and never reach it. Should be closer to the line. And it's going to closer and closer and closer to this asymptote and never reach it. Okay, if we'd never drawn these before, that'd be a horrible introduction to reciprocal functions. But we did this last year, so that's actually all I'm going to say about that. If you don't remember how to graph these things, you should go back and look at PreCalculus 11 reciprocal functions, and it's all there for you. Okay, here's another one we haven't done before. X, Y. So let's do them one at a time. Negative 3. The square root of negative 3. You can't do the square root of negative 3, right? You can never have a negative in there. So there's no point in writing down negative 2. There's no point in writing down negative 1. Let's go to 0. Can you take the square root of 0? Yeah, square root of 0 is 0. How about 1? Can you take the square root of 1? Yeah, you can take the square root of 1. It's 1. How about 2? Can you take the square root of 2? You can take the square root of 2. You could throw it in a calculator and get something like 1.41 or something like that. But what would be a better number to use instead of 2 here? How about 4? Why is that a better number used? Because the square root of 4, we don't need any stinking calculator. The square root of 4 is 2. What would be the next great number to use? How about 9? The square root of 9 is 3. Okay, this is enough points. Can't graph the first one. 0, 0, 1, 1, 4, 2, and 9, 3. Okay, this is the mother function for square root functions. Okay, so as I said, the reason that we have to learn these mother functions is now what we're going to do is we're going to transform them to get all sorts of other graphs. Transformation are, I suppose, operations that move a function from an original position to a new position. So we're going to take these mother functions and we're going to move them. How can we move them, or how can we change them? We can do 3 things. We can do a translation, which could be, we did this last year, it could be a vertical shift, meaning moving the graph up or down. We did that last year with our parabolas. Sometimes the vertex wasn't at 0, 0, right? Sometimes our parabola was moved up here, or sometimes the vertex was moved down here. Those are vertical shifts. You could also do for translations a horizontal shift. So move to the left or the right. Those are the 2 types of translations we'll be dealing with. Okay, the next type of transformation there are reflections. We did this last year, although we only did one type of reflection. We did a reflection over the x-axis. This year we'll also be looking at reflections over the y-axis. Okay, over the x-axis, remember that's when the parabola faced downwards instead of upwards. It opened downwards. And finally, we did this as well, stretches. And we didn't call it this. Remember last year we called it skinny or wide parabolas. That parabola is skinny, or that parabola is wide, or whatever. This year we're going to use the real terminology. So you have compressions, and you have stretches. And I don't know, I suppose I could have used all this language last year. I thought that we could try to get the basics last year and then move on to the more formal language this year. For any function, y equals f of x, once you've done the transformations, like once you've done your reflections, or once you've done your translations, or once you've done your stretches, you can end up with an equation that's been changed from y equals fx. It can look as complicated as something like this. It could look like y equals a f of b times x minus c plus d. What does that mean? Well, that means, as you can see, we've changed y equals fx to y equals all this. We've added a whole bunch of things. We've added an a b, a c, and a d. And each of those letters does something to the graph. Right? If it was y equals x squared, we did this last year. If it was y equals x squared, and then I changed it, that's a parabola, right? It looks like this. And then I changed it, I made it an a value of -2. So now the new graph would be y equals -2x squared. Would the graph look the same? No, there'd be two changes. The negative would reflect it, so it would now face downwards, and the 2 would make it narrow. So it would now look like this. Right? That's what it's talking about here. That's what the a would do in this case. If we had a number here in this b spot, that would do something. If we had a number here in the c spot, that would do something. You know what that c does. We did it last year. If we had a number in this d spot, that would do something. You know what that would do. We did it last year. You might not remember right now, but you'll see. You've actually done a lot of this. Okay, so the first thing I want to do here for these three questions, I just want us to identify what is f of x, what is a, what is b, what is c, and what is d. So you're comparing it to this and figuring out what each of these things are. Okay, f of x. What I mean by that is if you look at this equation right here, what's the function that's being used? Which one of these mother functions is coming into place? Is it y equals x squared? Is it y equals x cubed? Is it y equals the opposite value of x? Is it y equals 1 over x? Or is it y equals the square root of x? Which one of those things do you see in there? It looks to me like I see a y equals blah, 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 x squared. The function, the basic function there is y equals x squared. And then a whole bunch of things have been added, a, b, c, and d letters to make it look so complicated. What's the a value in this case? Well, the a value is the thing that's in front of the function, so it's in front of the x squared part. Oh, the a value is 1/2. What's the b value? The b value is in front of the x. So the b value in this case is just 1. It's kind of like if we put it in this form, we would have a square bracket here. Whoops. We would have a square bracket here. And the b value is found right in front of that bracket right here. Right here. Well, what number is there there? There's no number there, which means it is a 1. Next one, c. What number is there for c? It is 3. How about d? 2. Remember, for this value, we did this last year, you take the opposite in what it looks like. Since it's -3, it becomes +3. Why is that? Because it says x minus c. So you need to have a positive c in there, so that becomes x take away c. If you had a negative c, that would be x take away negative. It would actually look like x plus c. Just remember, it's always kind of opposite in that one. We did that last year. All right, let's do the next one faster. F of x. What's the basic function we see here? The basic function is absolute value of x. What's the a value? A value comes in front of the function. It's -2. B value comes inside the function, but before the x and all that stuff. Oh, so there's our b value 4. C value is 3. Take the opposite of that one. It's 3. D value, -1. Okay, next one. Little trick on this one, you need to rewrite this. This is not in this basic form. Now, one thing you probably notice is in this case, y is all by itself and y is not all by itself there. So you're going to move this over, it's going to become -6. But believe it or not, there's something else you have to do. So we have y equals 2 square root, and then when we bring the 6 over, it's going to be -6. Do you see that this part in the square root sign is also not of this form? How come? Because you can factor out a 3 from both of these terms. You can factor out 3 and be left with x minus 3. You always need it to be just x here, okay? So if you have a couple terms in here, you need to factor out that first term, just like we did here. So now it's in the correct form. F of x in this case, well, the basic function here is square root of x. The a value is out front, it's 2. The b value is inside the function, but it's in front of the x, so it's 3. The c value is 3, and the d value is -6. Okay, we're going to learn what all these letters do to the mother functions. And we've actually, as I said before, we've actually learned a bunch of them before. So it's kind of review, but we're doing it with a whole bunch of mother functions instead of just the quadratic function, Yeah. So translations of y equals fx with point mn. So we're only going to do two things today. We're going to do translations and we're going to do reflections. We'll leave the stretches for next day. So translations, there's four types of translations. I guess before I said there was two. There was vertical and horizontal, but you could have vertical translations upwards or you could have vertical translations downwards. You could have horizontal translations to the right or you could have horizontal translations to the left. Now, what these look like is if it's a vertical translation upward, you remember what that looked like? That would be like y equals, let's change our colors here, I've got too much red going on here. Let's make it blue. It would look like y equals fx, and if we wanted it to move upwards, which one of these numbers up here would make something move upward? It'd be like this, right? This +2, that makes the parabola move upwards. So what is that? That's d. So it's fx plus d. That's making it go up. What would make it go downwards? If it was y equals fx minus d. If we started at the point mn, where would any point on this function that we call mn, where would that point be now? Well, if it's only moving up and down, would it change the x value at all? In this case, the m? No, that wouldn't change. It would still be m. But what's now going to happen to the y value, or in this case, n? If you're moving it up by d units, it would now be n plus d. So maybe an example would help here. If I had, just let me graph down here for a second. If I graph the mother function for, say I wanted to graph this, y equals x squared plus 4. Now I know the way we did it last year is we kind of said, well, the vertex is at 0, 4, boom, go, draw it. But I want you to think of it this way this year. It's kind of like taking the mother function, which looks like this. Remember, it goes through 0, 0, 1, 1, 2, 4, 3, 9. See, I can draw this really fast. You should be able to do the same. It's kind of like taking that and doing a vertical shift, since it's +4 out here, doing a vertical shift, moving all these points up 4. Move this one up 4, 1, 2, 3, 4. Move this one up 4, 1, 2, 3, 4. Move this one up 4, 1, 2, 3, 4. And move this one up 4, 1, 2, 3, 4. It's up there somewhere. So you get like that. And do the same here, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. And it looks like that. Okay, that is a vertical shift. We've moved the whole parabola upwards. And as I'm saying, for each one of these points, if this point here is 1, 1, because it is 1, 1, where did that move to? It moved to 5, 1. Sorry, it moved to 1, 5. 1, 5. Do you see that the x value stayed exactly the same? So if originally we had an x value of 1, it stayed at 1. If originally we had an x value of 0, it stayed at 0. If originally we had an x value of m, it stayed at m. But the y value, what happened to it? It moved up by 4. So if we originally had a y value of 1, it moved up to 5. If we originally had a y value of 4, it moved up to 8. If we originally had a y value of n, it moved up to n plus d. Okay? What would happen here if you did a vertical translation downward? The x value would stay the same, but your y value would now decrease by d. Those are vertical translations, and as I said, we did them last year with our parabolas. Okay, similarly, horizontal translation, what does that look like? Well, that looks like y equals f, and inside the function, x is going to be plus or minus, if it's going to the right, minus c. And if it's a horizontal translation to the left, it looks like y equals f x plus c. Why did I put c here? Because it's the c, if you look back up here, it's the c letter that impacts whether it goes left or right. So I'm just trying to key you into which letter in this master function up here, this master equation, which letter is it you have to look for when you're looking at horizontal translations. It's the C. The D here is for the vertical translations, right? We called it D for the vertical translations. Okay, so if it's a horizontal translation to the right, does that impact the y values at all? No. The y value, if it started up at n, it's still going to be at n. But if it's going to the right, what's our new x value? It's not going to be m anymore. It's going to be m, be careful, plus c, because remember it's going to the right. If it is going to the left, it's going to be m minus c. and then the n value stays the same. You have a reflection over the x-axis, and you've got reflections over the y-axis. Now, we talked about reflections over the x-axis last year. That looked like this: y equals negative fx. So, for example, if our mother function is y equals x squared, so 0, 0, 1, 1, 2, 4, 3, 9, and here, here, and there. Here's our mother function. That's what the mother function parabola or quadratic function looks like. If we made it y equals negative x squared, do you remember what happens? It faces downward, so all your points are going to be reflected. Well, this is on the x-axis, so it stays exactly the same spot. This one was above by 1, so it goes down by 1. This one was up by 4, so it now ends up down by 4. It's like a mirror here, right? This one was up by 1, down 1. This one stayed the same. This one went down to here. This one was up 9, so it goes down 9. Same with the one here. So you end up reflecting it over the x-axis. Here's the x-axis. That's like our mirror line. That's what happens when it looks like this. So what would be our new point? It was mn. Right here, mn. What's our point now going to be? Well, for any of these points on here, like if I take a look at this point right here, this was 2, 4, and it got reflected down to 2, negative 4. Did it change the x value at all? No, the x value stayed exactly the same. So it's still going to be m, if we called the x value m. But what's the n value now? It's not 4 anymore, it's negative 4. It's not 1 anymore, it's negative 1. It's not n anymore, it's negative n. And finally, reflection over the y-axis. We did not do this last year. This looks almost the same, confuses some people. It looks like y equals f of negative x. Maybe do an example of that. Let's hold on. We'll do an example of that in a bit. I'll just tell you that the way what it does is it changes your x value, in this case m, to negative m, but it doesn't change the y value. All right, let's graph a few of these, and you'll hopefully get an idea of how this works. So let's start by graphing y equals the square root of x plus 2. So what you want to do first is you want to graph the mother function. So the mother function is just y equals the square root of x. What's that look like? Oh, I can remember that one. If you don't remember, look back at our mother function page, just on the last page. It goes through 0, 0, it goes through 1, 1, it goes through 4, 2, and it goes through 9, 3. There's my mother function. This is y equals root x. Now, this is different. This is y equals root x plus 2. Which letter is that? Where's that plus 2 fit into this? That's outside the function. It's not inside the root x, so it's outside the function. Plus d, so it's right there. So it's a vertical translation. It's going to move it 2 upwards. So all you have to do is take each of these points and move them up 2. 1, 2, 1, 2, 1, 2, 1, 2. This is the graph of y equals root x plus 2. Okay, let's do another one. How about y equals x minus 3 cubed? Okay, we start by drawing the mother function, which is y equals x cubed. X cubed, I remember it went through negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, 2, 8. If you don't remember that, look it up on our list, but you got to get familiar with those. Something like that. Okay, this switch here, which letter is that? It's an x minus 3 cubed. Oh, that minus 3 is inside the function. So that must be the c. If it's x minus 3, is that a shift to the right or to the left? If it's minus, we shift to the right 3 spots. We take every point and move it over 3 to the right. So this was here. We go over 1, 2, 3. This point here goes over 1, 2, 3. This point goes over 1, 2, 3, 1, 2, 3, and 1, 2, 3. This is now the graph. Y equals x minus 3 cubed. This one here is just y equals x cubed. Getting the idea? You just take the mother function and do whatever transformation it's asking you to do. Let's graph y equals negative the square root of x. Okay, here's the reflections. Now, how we're going to start is by graphing y equals root x. Hey, we just did that over here, so we can very quickly do that. 0, 0, 1, 1, 4, 2, 9, 3. Okay, what's this negative? Where's that negative belong? That negative is outside the function. It's not inside the function, it's outside the function. So that is this a value here. The a value is negative. So if you look at our reflections, if the negative's outside the function like this, that is going to reflect over the x-axis. It's like a mirror on the x-axis. So how will that look? It'll look like, if there's a mirror here, this point stays the same. This one goes down here. This one was up 2, so it goes down 2. This one was up 3, 1, 2, 3. It goes down 3, 1, 2, 3. This is the graph. Y equals negative root x. The one up top here was y equals root x. Okay, let us now graph y equals root negative x. We never did this last year. So this is a little different. This negative sign's inside the function. It's like this. So this is a reflection over the y-axis. So you would start by drawing the same mother function, but then you'd reflect all the points over the y-axis, over this one. This point would stay the same. It's right on the y-axis. This point would go 1 over here. This point's 1, 2, 3, 4, so it would go 1, 2, 3, 4. And this point here is over 9 from the y-axis. It would go 9 over this way. This graph, a reflection over the y-axis, is y equals root negative x. Now, you'll notice that I keep talking about inside the function, outside the function. Up here, maybe we should add that a plus d, a and d are outside the function, right? A is not in the function, D is not in the function. The function is all this square bracketed part. That's all in the function. A and D are not in the function. They're outside the function. And they impact the y values. And then B and C, which are inside the function, impact the x values. Okay, that's important. By the way, you could also graph y equals negative the square root of negative x. What would you have to do for that? You'd have to take the mother function, reflect it over the x-axis and the y-axis. You'd end up something like this. Like that. Whoa, I missed. Yeah, right there. You reflect it. Doesn't matter which way you reflect it first. You could either first of all reflect it over the y-axis and then over the x-axis, or you could reflect it over the x-axis and then over to the y-axis. Anyway, this right here is y equals negative root negative x. Crazy, eh? Okay, last one. Let's do one that has a whole bunch of different things in it. So let's graph y equals negative the absolute value of x minus 3 plus 2. Okay, so what do we start with? We start with the mother function. What's the function? It's an absolute value function. Oh, that's the v. So it goes here, 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 and it just goes straight and straight. Now, we have a reflection with that negative, and we also have some translations. So a very important fact is do the translations, which is actually the easiest part, I think. The sliding part, a lot of people want to do the sliding part first, but you have to do the translations last. So we're going to do our reflection first. So first of all, this negative here, is that inside the function or outside? That's outside the function. So that looks like this. So is that a reflection over the x or the y? It's a reflection over the x. So we're now going to reflect this. So I'll reflect this graph here. So this point would come to here. I guess I'll do it in a different color. Yeah. This point would stay the same. This point would come to here. This point would go down 2. This point would go down 3. This point would go here, here, here. Oh, I get the idea. It's just going to look like that. and that. Whoops. Like that. Now, if you want, you can take your eraser or whatever, and you can say, I'm done with this, right? This actually isn't part of the graph. It was just getting me. This isn't even the final answer, because now, what do you have to do to get the final answer? I've already done the reflection. How am I going to now move this thing? Think of the parabola. If it looked like this, you would move it 3 to the right, right? Do the opposite of that. 3 to the right and 2 up. Okay, pick a point, go 3 right, 2 up. Pick another point, go 1, 2, 3, 1, 2. Pick another point, 1, 2, 3, 1, 2. I don't know why I'm doing this weird order. Let's do this point, 1, 2, 3, 1, 2. Oh, wait a minute, I think I understand what this looks like. 1, 2, 3, 1, 2. Yes, I totally get what this looks like. It looks like something like this. Anyway, you could do a better job with a ruler and doing more points and everything, but you get the basic idea. If you wanted to, you could go back and erase the red one, because that's not part of the graph either, right? It just helped us get the graph. The green is the actual answer. That graph right there is the graph for y equals negative the absolute value of x minus 3 plus 2. Now, what happened to the point? The last thing, we started off with the point. This is called a mapping. Mapping. You don't have to know that. But anyway, we started off with the point mn, let's call it. mn. Any point on that original graph, which I suppose I could draw again. The original one looks something like this, right? Any point on there ended up with a related point on this green one. What was the relation? What did we do to mn to get our new points? Well, the first thing we did is we reflected it over the x-axis. Did that impact the x values? No. If it was a point here at -2, then when we got our new point, it was still at -2. So it didn't do anything to m. Did it do anything to n's? Yes, all the n's became negative. So the first thing it did is we got negative n, and then we moved our point 3 to the right. Oh, that's like m plus 3, moving it 3 to the right, and 2 up. There you go. This is what you do to any single point on there. So if you want to know where the point 6, 6 is going to end up, the point 6, 6 originally is going to end up at 6 plus 3 is 9. -6, right? -6 plus 2 is -4. So we should have a point at 9, -4. 9, -1, 2, 3, 4. This point here is where this point ended up. It was here, and after our transformations, it ended up there. This is very useful to figure out the mapping like this. And next time we're going to talk more about how to figure out the mapping, and I think you'll figure that that's a pretty useful way to do all these transformation graphs. Okay, happy graphing, everyone.
I can't hear your voice, do I have a choice?
You're sinking below, I'm using my force.
I'm hoping with chance you might take